9 categories of specific student learning outcomes. Cluster 0 comprises 9 categories of specific student learning outcomes, SLOs, that describe the skills and attitudes involved in scientific inquiry, the design process, or both. In scientific inquiry at grades 7 and 8, students build on the concept of a fair test developed in grades 5 and 6. This includes developing a prediction/hypothesis that identifies a cause and effect relationship between dependent and independent variables, repeating experiments to increase accuracy and reliability, looking for alternative explanations for observations, recognizing strengths and weaknesses of different methods of collecting and displaying data, and determining potential sources of error. In the design process, students construct prototypes to solve practical problems and analyze them according to criteria such as cost, efficiency, and environmental considerations. Students continue to apply their problem-solving skills in the evaluation of consumer products in order to determine the best product for a particular purpose. This involves identifying priorities. For example, in choosing a brand of sunscreen, to what extent do cost, effectiveness, and the environmental track record of the company affect the decision? Although the thematic clusters 1 to 4, include certain skills and attitudes, Cluster 0 fully defines scientific inquiry and design process skills and attitudes at each grade. Teachers should select appropriate context to introduce and reinforce Cluster 0 SLOs over the course of the school year. To assist in planning and to facilitate curricular integration, many SLOs within Cluster 0 are accompanied by links to SLOs in other subject areas, specifically English Language Arts, ELA, and Mathematics, Math. There are also links to technology as a foundation skill area, TFS. Grade 7, Cluster 1, Interactions within Ecosystems Overview. In this cluster, students investigate the complex interactions between organisms and their environment. Students identify biotic and abiotic components of ecosystems and analyze the cycling of matter that takes place within them. This includes an investigation of the transfer of energy that occurs at various consumer levels, the implications of the loss of producers and consumers to the transfer of energy, and the potential for bioaccumulation within an ecosystem. Students explore ecological succession and assess the positive and negative impacts of human interventions on this natural process. Students discuss environmental, social, and economic factors that should be considered in the management and preservation of ecosystems. They propose a course of action that would help protect the habitat of a particular organism. Students observe microorganisms with microscopes and discuss their beneficial and harmful roles. Students consider how knowledge of microorganisms has improved food production and preservation techniques. Students will use appropriate vocabulary related to their investigations of interactions within ecosystems. Include ecosystem, biosphere, abiotic, biotic, organisms, ecological succession, photosynthesis, cellular respiration, ecological pyramid, bioaccumulation, scavengers, decomposers, microorganisms. Define ecosystem and describe various examples that range from the microscopic to the entire biosphere. Include a place on Earth where living things interact with other living things as well as non-living things. Identify abiotic and biotic components of ecosystems that allow particular organisms to survive. Describe ecological succession and identify signs of succession in a variety of ecosystems. Include the natural process whereby some species are replaced by other species in a predictable pattern. Specific learning outcomes 5 to 8 science. Identify and describe positive and negative examples of human interventions that have an impact on ecological succession or the makeup of ecosystems. Examples: positive, protecting habitats, reintroducing species; negative, preventing natural fires, introducing non-indigenous species, draining wetlands for agriculture or housing. Identify environmental, social, and economic factors that should be considered in the management and preservation of ecosystems. Examples: habitat preservation, recreation, employment, industrial growth, resource development. Propose a course of action to protect the habitat of a particular organism within an ecosystem. Examples: protect the nesting habitat of a given bird in a local wetland. Compare photosynthesis to cellular respiration and explain how both are part of the cycling of matter and the transfer of energy in ecosystems. Include photosynthesis, Water plus carbon dioxide plus light energy equals sugar plus oxygen in the presence of chlorophyll. Cellular respiration. Sugar plus oxygen equals water plus carbon dioxide plus energy. Analyze food webs using ecological pyramids to show energy gained or lost at various consumer levels. Include producers, primary, secondary, and tertiary consumers. Analyze, using ecological pyramids, the implications of the loss of producers and consumers to the transfer of energy within an ecosystem. Explain, using ecological pyramids, the potential for bioaccumulation within an ecosystem. Provide examples of scavengers and decomposers, and describe their role in cycling matter in an ecosystem. Include microorganisms. Demonstrate proper use and care of the microscope to observe microorganisms. Include preparing wet mounts beginning with the least powerful lens, focusing, drawing specimens, indicating magnification. Science-specific learning outcomes. Identify beneficial and harmful roles played by microorganisms. Examples: beneficial, aid in digestion, composting, food and vaccine production; harmful, cause disease, food spoilage. Research and describe human food production or preservation techniques that apply a knowledge of microorganisms. Examples: bread and yogurt making, food drying, sterilization, refrigeration. Grade 7, Cluster 2, Particle Theory of Matter Overview. In this cluster, students explore the nature of science by examining the development of scientific theories. One theory, the particle theory of matter, is investigated in detail. Students use the particle theory to describe changes of state, to differentiate between pure substances and mixtures, and to describe characteristics of solutions. An important distinction is made between heat and temperature. Students demonstrate how heat is transmitted by way of conduction, convection, and radiation. They plan and conduct experiments to identify substances that are good insulators and conductors of heat. They apply this knowledge through the design and construction of a prototype that controls the transfer of heat energy. Students also identify different forms of energy that can be transformed into heat energy, and recognize that heat is the most common byproduct of other energy transformations. Students classify substances used in daily life as pure substances, mechanical mixtures, and solutions. They demonstrate different methods of separating the components of mixtures. Students experiment to determine factors that affect solubility. They describe the concentration of solutions in qualitative and quantitative terms, and demonstrate the differences between saturated and unsaturated solutions. The potential harmful effects of some substances on the environment are discussed, and methods to ensure safe use and disposal are identified. Students will use appropriate vocabulary related to their investigations of the particle theory of matter. Include boiling and melting points, pure substance, scientific theory, particle theory of matter, temperature, heat, conduction, convection, radiation, mixture, solution, mechanical mixture, homogeneous, heterogeneous, solutes, solvents, solubility, concentration, dilute, concentrated, saturated, unsaturated, terms related to forms of energy. Evaluate different types of thermometers using the design process. Examples: materials used, range, sensitivity, durability, scale, cost. Demonstrate the effects of heating and cooling on the volume of solids, liquids, and gases, and give examples from daily life. Compare the boiling and melting points of a variety of substances and recognize that boiling and melting points are properties of pure substances. Include water. Specific learning outcomes 5 to 8 science. Explain what scientific theories are, and provide some examples. Include a scientific theory helps to explain an observation. When this explanation has been repeatedly tested and shown to be consistent, it is generally accepted in the scientific world. Describe the particle theory of matter and use it to explain changes of state. Differentiate between the concept of temperature and the concept of heat. Demonstrate how heat can be transmitted through solids, liquids, and gases. Include conduction, convection, radiation. Plan an experiment to identify materials that are good heat insulators and good heat conductors, and describe some uses of these materials. Use the design process to construct a prototype that controls the transfer of heat energy. Examples: insulated lunch bag, solar oven, home insulation. Recognize that heat energy is the most common byproduct of energy transformations, and describe some examples. Examples: thermal pollution, body heat, friction. Identify different forms of energy that can be transformed into heat energy. Include mechanical, chemical, nuclear, electrical. Differentiate between pure substances and mixtures by using the particle theory of matter. Include: a pure substance is made up of one type of particle, a mixture is made up of two or more types of particles. Differentiate between the two types of mixtures, solutions and mechanical mixtures. Include: solutions, homogeneous; mechanical mixtures, heterogeneous mixtures. Classify a variety of substances used in daily life as pure substances, solutions, or mechanical mixtures. Examples: distilled water, paint thinner, mouthwash, peanut butter, liquid soap, medicines, sunscreens. Science-specific learning outcomes. Demonstrate the difference between saturated and unsaturated solutions. Discuss the potential harmful effects of some substances on the environment, and identify methods to ensure their safe use and disposal. Examples: pollution of groundwater from improper disposal of paints and solvents, pollution of the atmosphere by car exhaust. Identify solutes and solvents in common solid, liquid, and gaseous solutions. Describe solutions by using the particle theory of matter. Include: particles have an attraction for each other. The attraction between the particles of solute and solvent keeps them in solution. Demonstrate different methods of separating the components of both solutions and mechanical mixtures. Examples: distillation, chromatography, evaporation, sieving, dissolving, filtration, decanting, magnetism, sedimentation. Identify a separation technique used in industry, and explain why it is appropriate. Experiment to determine factors that affect solubility. Include: agitation, surface area, temperature. Describe the concentration of a solution in qualitative and quantitative terms, and give examples from daily life when the concentration of a solution influences its usefulness. Include: dilute, concentrated, grams of solute per 100 milliliters. Grade 7, Cluster 3, Forces and Structures. Overview. In this cluster, students explore a variety of natural and human-built structures, and the forces that act on them. Students investigate internal and external forces acting on structures and recognize that these forces may affect structural strength and stability. Students identify common shapes used to increase strength and stability in structures, and methods used to enhance the strength of the materials used. The efficiency of a structure is assessed by comparing its mass with the mass of the load it supports. Students apply their understanding of forces and structures by evaluating the appropriateness of a specific structure's design, and by constructing a structure of their own that supports a given load and remains standing when a particular force is applied. Students will use appropriate vocabulary related to their investigations of forces and structures. Include: frame, shell, solid, center of gravity, stability, compression, tension, shear, torsion, internal and external forces, stress, structural fatigue, structural failure, load, magnitude, point and plane of application, efficiency. Classify natural and human-built structures found locally and around the world. Include: frame, shell, solid. Identify the center of gravity in a model structure, and demonstrate that changes in the location of a structure's center of gravity affect its stability. Identify internal forces acting on a structure, and describe them using diagrams. Include: compression, tension, shear, torsion. Identify external forces acting on a structure, and describe them using diagrams. Examples: snow on a rooftop, wind on a tent, water against a beaver dam. Specific learning outcomes 5 to 8 science. Recognize that internal and external forces apply stress to structures, and describe examples in which this stress has led to structural fatigue or structural failure. Investigate to determine that the effect of a force on a structure depends on its magnitude, direction, and point and plane of application. Describe, using diagrams, how common structural shapes and components can increase the strength and stability of a structure. Examples: a triangle distributes the downward force of a load evenly between its two vertices. Describe and demonstrate methods to increase the strength of materials. Examples: corrugation of surfaces, lamination of adjacent members, alteration of the shape of components. Determine the efficiency of a structure by comparing its mass with the mass of the load it supports. Evaluate a structure to determine the appropriateness of its design, using the design process. Examples: jacket, footstool, local building. Use the design process to construct a structure that will withstand the application of an external force. Examples: a tower that will remain standing during a simulated earthquake. 5 to 8 science-specific learning outcomes. Grade 7, Cluster 4, Earth's Crust. Overview. In this cluster, students investigate Earth geology, including rock and mineral formation, changes in the landscape over time, and human use of geological resources. Students describe processes involved in the location, extraction, processing, and recycling of geological resources found in Manitoba and Canada. Students recognize that soil is an important natural resource and they discuss the importance of soil conservation. Students identify environmental, social, and economic factors that should be considered in making informed decisions about land use. They examine theories explaining the Earth's geology and recognize the role of technology in the development of new scientific theories. Specialized careers involving the science and technology of the Earth's crust are also explored. Students will use appropriate vocabulary related to their investigations of the Earth's crust. Include crust, mantle, outer core, inner core, weathering, physical, biological, and chemical, erosion, rock cycle, fossil fuel, geothermal energy, continental drift theory, theory of plate tectonics. Describe the Earth's structure. Include crust, mantle, outer core, inner core. Describe the geological processes involved in rock and mineral formation, and classify rocks and minerals by their method of formation. Investigate and describe the processes of weathering and erosion, and recognize that they cause changes in the landscape over time. Include physical, biological, and chemical weathering. Explain how rocks on the Earth constantly undergo a slow process of change through the rock cycle. Specific learning outcomes 5 to 8 science. Identify geological resources that are used by humans as sources of energy, and describe their method of formation. Include fossil fuels, geothermal energy. Identify geological resources that are present in Manitoba and Canada, and describe the processes involved in their location, extraction, processing, and recycling. Include fossil fuels, minerals. Identify environmental impacts of geological resource extraction, and describe techniques used to address these. Recognize that soil is a natural resource, and explain how the characteristics of soil determine its use. Describe methods used to control soil erosion, and recognize the importance of soil conservation. Examples: economically important to the agri-food industry, important for controlling the flow of water, necessary for plant growth. Identify environmental, social, and economic factors that should be considered in making informed decisions about land use. Describe evidence used to support the continental drift theory, and explain why this theory was not generally accepted by scientists. Describe evidence used to support the theory of plate tectonics, the role technology has played in the development of this theory, and reasons why it is generally accepted by scientists. Explain geological processes and events using the theory of plate tectonics. Include mountain formation, earthquakes, volcanoes. Identify specialized careers involving the study of the Earth's crust or the utilization of geological resources, and give examples of technologies used in each. Examples: geophysicist, seismologist, volcanologist, farmer. Cluster 0 comprises 9 categories of specific student learning outcomes,